Welcome to the Evergreen Thumb, your go-to podcast for up-to-date research-based horticulture and environmental stewardship knowledge to help you grow and manage your garden. Produced by Washington State University Extension Master Gardener volunteers and brought to you by the Master Gardener Foundation of Washington State. I'm your host, Erin Hoover, a WSU Extension Master Gardener since 2015 and a certified permaculture designer and modern homesteader. WSU Master Gardener volunteers are university-trained community educators who have been cultivating plants, people, and communities since 1973. Are you ready to grow? Let's dig into today's episode. Welcome to the Evergreen Thumb, episode 37. My guest today is Theresa Crimmins, and she is the director of the USA National Phenology Network. She works with an amazing team to support the growth and use of phenology data and resources as curated by the USA NPN, involvement in Nature's Notebook, and a broader appreciation of phenology among scientists and non-scientists alike. Theresa is also an associate professor in the School of Natural Resources and the Environment at the University of Arizona and has published over 70 peer-reviewed articles and book chapters. Her book, Phenology, will be available through MIT Press in March 2025. Theresa, thanks for joining me today. Welcome.
Thanks so much for inviting me. I'm excited to speak with you.
All right. Well, so you're here today to talk to us about phenology, and so we'll talk a little bit more about that in a minute. But to start off, why don't you tell us a little bit about yourself and the organization that you work with?
Sure. So I am a plant ecologist by training. I grew up in the Midwest, but now I am situated here in southern Arizona, and I'm an associate professor here at the University of Arizona in the School of Natural Resources and the Environment. And the bulk of what I do is to direct the USA National Phenology Network. And so we care an awful lot about seasonality and when things are happening in plants and animals over the course of the year. And so it's almost ironic, honestly, that I ended up here in southern Arizona where the seasonality is really a lot more muted than it is in much of the rest of the country, where there are 4 distinct seasons and very apparent ways in which plants and animals are responding to those changes in the season. So, but yeah, I really love it here. It's very beautiful.
Well, I guess that leads us into the first question is what exactly is phenology and how does it relate to gardening?
I am never not asked what the heck is phenology because it's such an awkward word, but it's an awkward and unfamiliar word for a phenomena that we are all so intimately familiar with, especially those of us that really like to garden and be outside in our yards. It is the old-fashioned term for when things happen seasonally in animals and plants. So those recurring biological events that really are markers or harbingers of the seasons. So when different species bloom in the spring or put on their leaves, or when those leaves start to change color and fall off, when fruits are ripening, when eggs hatch, when animals go in and out of hibernation. The majority of these events are cued by what local conditions have been in recent weeks and months, and typically things like sun angle and temperature. And so phenology is really the study of not only when things are happening, but what their relationship is to local environmental conditions too, because they really are a very strong response to environmental conditions. It's very related to gardening. It's very related to any activity where we are out on the landscape and trying to react or respond to how things are changing. Truly, an awareness and an understanding of phenology is something that has been around for likely as long as humans have been around, because back before we had refrigeration and even modern agriculture, folks were very, very dependent upon resource availability for their very survival. And being able to understand and anticipate when particular species would have fruits or other biological parts that are available for as a food resource to us is critical, really critical for our survival. And there's actually evidence from cave paintings dated back up to 40,000 years ago that show that humans did track very carefully the migration patterns of different animals and really carefully tracked when plants were undergoing different transitions too. And We are now familiar. A lot of gardeners are probably very familiar with what we tend to think of as folklore. These statements, things like plant corn when oak leaves are the size of a squirrel's ear, or protect apples from maggots when the Canada thistles are in bloom. These just seem like rules of thumb or adages that get passed down from one generation to another, but they originated, in a lot of cases, it was native communities and indigenous cultures that established these because they needed to know, they needed to be able to understand when are different food resources going to be available. And so there's honestly quite a strong record of that kind of information being carefully documented. For example, there are indigenous communities in Canada that still use the singing of Swainson's thrush, which is a bird, to which they refer to also as salmonberry bird, to know that now is the time that salmonberries, which are related to raspberries, are ripe and ready to pick. And so being able to understand that those two things are temporally connected can be really valuable for understanding when those things are actually available for consumption. And so really those kind of like rules of thumb exist because they are rooted in science and in long-term observations.
Can you explain more about the role of the phenological? It's a mouthful. Phenological indicators in predicting plant and animal behaviors?
Sure, yeah. So again, those adages, again, when think of those adages or those rules of thumb or even just folklore, again, the planting corn when oak leaves are the size of a squirrel's ear, that's a really excellent example of using a biological indicator. So, being able to just keep track of your oaks and when they're actually putting on their leaves and when their leaves are getting big enough, that can be your indicator, your trigger for when to plant corn. The reason why that actually works is because by the time that oaks have little leaves on them that are the size of a squirrel's ear, that means that's basically a pretty good representation that the soil is now warm enough that the seeds won't rot. However, it's still early enough in the year that there's time for the crop to come to fruition and to have a good sizable harvest. And so there are actually loads of these. The Farmer's Almanac is one resource, but I have seen them repeated on Mother Earth News. And even if you just Google something along those lines, like when to plant X, when to plant Y, these things turn up. And it is because, folks have kept track of when things are happening and been able to draw these connections. And so really the science behind it is that in a lot of cases, the two events that are being considered are responding to very similar environmental conditions. So if we go back to the Swainson's thrush and the salmonberry bird example, both of those events are occurring at the same time because both of those species are responding to some sort of environmental cue. And in a lot of cases, it's actually warmth, it's temperature, although sun angle can often play a role as well.
Why should we care about phenology? What impact does it have?
We care a lot because it can help us in short-term planning. And we also care because it's actually changing. We have seen some really dramatic shifts in when events are occurring in recent decades as a direct consequence of increasing global temperatures. And there are so many examples of clear, dramatic shifts in the timing of events all around the globe. Because plants and animals are so responsive to local conditions, when we have warmer temperatures, we tend to see events occurring earlier in the spring than they used to, and oftentimes later into the fall than they used to as well. And we see the impacts of this really dramatically, not only in natural and wild environments, but we see it in agriculture as well. There's been documentation of wine grapes now being harvested up to 4 weeks earlier in France, in parts of France, than we used to see several decades ago. Things like maple syrup production is being impacted. That's shifting much earlier in the year and becoming a lot more chaotic in terms of when the sap is starting to run, as well as the trees that we tap for sap are now shifting further north. And a lot of our stone fruits and berry fruits, things like cherries and apricots and blueberries, require exposure to a particular amount of cold in the winter. And if they don't receive that sufficient chill, they won't produce nearly as large of a fruit crop in the spring. And that's actually starting to become a pretty big problem in certain parts of the world. So much so that agriculturalists are now experimenting with ways to try to trick plants into believing they did get exposed to cold even when they did not. And that's involving genetic modification as well as doing other things out in the field, like adding additional moisture and other things that can just confuse the plants. But changes in phenology stand to change not only what we see out our windows from one year to the next, but also what we see at the grocery store. And then it can have further impacts to things like our health. An earlier start to the growing season also tends to lead to an earlier start to the allergy season. And we are seeing not only a longer allergy season, but a more intense allergy season. We're also seeing impacts to the wildfire season as a consequence of this increased growing season. And a lot of ecologists are really concerned about the potential for more mismatches among species that depend upon one another. So plants and their pollinators are a classic example. And if we are, for example, looking at pollinators that are migrating, if their migration time isn't shifting at the same rate that, say, the flowers are advancing the timing of their activity in the season, that can result in a mismatch that can be really detrimental for both parties. So actually, unfortunately, changes in phenology stands to affect a lot of parts of our lives.
Okay. So specifically, how can gardeners use observations to optimize their planting and harvesting schedules?
Such a good question. And it's so great to bring it down to the practical, like, what does this mean for me? Um, Again, referring back to those established rules of thumb or guidelines is one way that can be used. And then in addition, folks can establish them on their own. I know of a number of folks who just really are interested in watching what's happening on their properties. And if you start to really track when things are happening in different species, you actually can begin to identify whether there are events that occur at the same time such that one can be a predictor for the other as well. And then that can be a rule of thumb. And I was just looking at some literature before we hopped on this call because I remembered that there is kind of a whole science around using biological events or phenological events as indicators for either when something else is going to happen or truly more practically when to take some sort of action. And it's very frequently invoked in planting and harvesting, but it is also used sometimes in things like invasive species management. So I found this one study where folks researched giant foxtail is a annual grass that's just a problem in both agricultural settings and can be just a roadside weed and troublesome in other places as well. And these researchers established that about 25% of giant foxtail seedlings have emerged when red chokecherry is first in bloom. And about 80% of those seedlings have emerged by the time multiflora rose is in full bloom. And so if you're trying to get out there and try to control this weed, and this was in a journal where they were trying to determine the optimal time to spread herbicide, actually, because this was in a crop setting. And so they were just using these chokecherries and multiflora roses that were planted in alongside the crops, and they were able to identify, like, okay, this is when we should go out and spread this herbicide. Because as you probably know, with an annual grass, when they're first coming up, it's tricky to identify them. And if you're waiting for that plant to reach a stage where you can actually identify it before you zap it with herbicide, you might have kind of missed your optimal treatment window. This is another way in which keeping track of when stuff is happening can be used in a really practical way.
So that kind of leads into my next question. It was about identifying the best times for weed control or pest control, keeping track of those observations of, like you said, the grass. But what kind of observations would we try to make about like pests that might be coming in?
Yeah, so another active area of research is to try to quantify the environmental conditions that seem to be associated with a particular phenological event. So I talked earlier about how a lot of times what initiates an event like leaf out or flowering in a species, or egg hatch in an insect, for example, oftentimes is how much warmth it's been exposed to. We can actually quantify that if we have sufficient observations of when an event has occurred, either across many locations or maybe at a single location, but over multiple years. We can compare those observation dates with what the weather conditions were like. And then it's oftentimes, if the data are good enough, possible to quantify, how much warmth does that organism need to be exposed to before those eggs begin to hatch, or those leaf buds start to crack open and reveal their tiny little leaflet. And then once you know that, you can actually use that in a predictive way, either locally with, weather observations that you're making right at your site, or there are increasing organizations that'll do this for you. And so my organization, the USA National Phenology Network, one of the things that we do is offer a series of real-time maps that we call phenoforecasts. What we do is ingest temperature data every single day from across the whole country. And then for particular pests, in most cases it's insects, but there are a couple of invasive grasses on there as well. We work with models that have been established, where researchers have figured out how much warmth does this organism need to be exposed to in order for it to undergo its transition and enter into a phase where it's actually most effectively managed. We make those predictions across the landscape, and they're updated on a nightly basis. And so if you are somebody who is concerned about things like apple maggot, you can go on there and watch your location to determine when is the optimal time for going out and making sure that you're preventing the damage of apple maggots, which can take a number of forms, but I know that some folks go put plastic baggies around the apples and it's a little labor intensive, but it can prevent the adults from laying their eggs in the fruit at that time. And these maps can help you understand when do you need to get out there, when have you missed the window they have optimal opportunity for preventing that, when are you too early.
Oh, that's interesting. So that made me think of, we have a solitary bee. It's a blue orchard mason bee, and it's a real early spring. It has to have so much warmth. I don't know exactly what it is, but that's it's an early pollinator for a lot of the early tree fruit like cherries and apples. So finding a correlation between them to know, how soon after bud break or how soon before bud break those bees hatch out would be interesting.
Yeah, I think we have mason bees available for monitoring. We'll get to this, I know, but we have about 2,000 species available for monitoring, and I don't know them all off the top of my head, but I think may be on the list. So it may be doable to do exactly what you are suggesting if someone hasn't already established that, and that may have been done, and I don't know that either.
So can you tell us a bit about any citizen science initiatives that are related to phenology?
Absolutely. So the one that I am definitely the most familiar with is the program, the program that we offer, which is called Nature's Notebook. And how it works is that you are invited to make repeated observations on organisms at a location. So what we're really trying to establish is when are organisms undergoing those seasonal transitions, like going from not having open flowers to having open flowers. And then again, at the tail end of the season, when do those flowers stop being in bloom? And so how it works is that you can download the Nature's Notebook app and it'll walk you through it. But the steps are basically to register yourself, then choose a location where you're comfortable making repeated observations, and then identifying organisms that we have on our list available for monitoring. There are about 2,000 plants and animals on there. And you select, in the case of plants, you're going to make repeated observations on the same individual. So I have a big desert willow in my backyard, and I make observations on that same desert willow every time I go out to make observations. In the case of animals, they don't stay still. So you instead are saying, I am trying to make observations on this particular species at this site. And then when you step out to make observations, you're documenting whether you see or hear that species. And then when you actually are making observations, you're prompted with a series of questions where the answers to them are phrased as yes or no. And so each time I observe, say on my desert willow, I am answering, do I see leaves? Yes or no. Do I see colored leaves? Yes or no. Do I see flower buds? Yes or no. Do I see open flowers? Yes or no. And that helps to construct a complete picture of what is happening at the moment that you're making that observation. And then if you repeat that through time, you can understand when did the different events begin and end. And they oftentimes are overlapping. And so that's why we're asking about all of them at once. And then in addition, if you answer yes to any of those events, you are invited to submit information as to how many or how much. And so if I said, yes, I do see open flowers, then I'm prompted with what proportion of the flower buds are open today. And the intent with these data, the protocols are somewhat rigorous. It's a bit demanding to get going, though once you get up and running, it is relatively quick to actually make observations. The intention is that we are generating data that are of sufficient quality and rigor that they can be used by scientists in scientific discovery and in management decisions. The Nature's Notebook program and the data that are emerging from the program are really viewed as kind of like the premier phenology data resource in the country. And these data are used in dozens of scientific studies every year, both by graduate students and professional scientists. And they are revealing really important patterns and changes that we otherwise really wouldn't understand. So it can be a really cool experience to get involved because it's another way to invite you outside and to pay more attention to what's happening in your yard. And you're generating data that actually are really important for understanding how ecosystems and individual species are responding to rapidly changing conditions. So we are always very enthusiastic for anybody to join, and you can learn more at naturesnotebook.org or by downloading the app. And the one thing that I will mention, especially since this is a Master Gardener podcast, is that folks can observe and participate as individuals, but we also put a lot of emphasis on engaging groups of folks in observing. And Master Gardener chapters are actually one of our common groups that participate. So how this works is if there's an established group of folks, and it could be like docents at a nature center or volunteers at a arboretum in town, or folks that are part of a Master Gardener chapter, they can choose to collectively participate in Nature's Notebook. And oftentimes what that involves is sharing the responsibility of making observations on the same plants at a location, especially if it's a group that's situated at a physical location like an arboreta or a school. But we have a lot of variety in how groups participate. And the group model is so great because, and again, I feel like Master Gardeners are pros at this. You already know this. You learn so much from each other, and there's so much fun and camaraderie and enthusiasm in that act of participating in something together and then sharing. And we see amazing, really amazing things come out of the groups that are participating in the program. I'm always like, oh man, I want to be part of that group. I know of folks that it's morphed into book clubs. They read nature themed books together. They make acorn pancakes. They learn so much about the species that they are observing, and it really blossoms, pardon the pun, into other cool activities and relationships. And so, we are more than happy. We have a fabulous staff here, and we're more than happy to help folks get up and running if there's excitement in getting involved in this.
I could see using that in some of our demonstration gardens where we have a native plant garden in one of our demonstration gardens. And so being able to track, and, any master gardener who comes into the garden can track the changes in those plants over the year.
That's a perfect model, honestly. Yes, definitely.
So, and now I can see too, because my next question was about climate change, and we kind of talked about that a little bit already, but how tracking this data through Nature's Notebook can really kind of inform on how climate change is affecting the timing of these things.
Indeed, yes. Yeah, our data are starting to really tell much richer stories about that, especially in this country. Prior to the USA National Phenology Network getting established in 2007, we didn't really have a whole lot of intensive phenology data collection across large regions. There were a couple of discrete, intense local efforts, but we really have spread it across the landscape. And yeah, these data have been used to document all sorts of things. Things like invasive plants tend to leaf out and flower earlier in the season than natives do, and that plays a big role in their success on the landscape. We see that in more urban areas, plants tend to leaf out and flower earlier in the season than in their rural counterparts, both as a function of urban heat island effects and the artificial light that cities tend to have. We see differential responses in different regions. We are seeing different rates of change in not only among different species, but in different seasons too. So yeah, the data really are helping us understand with a more complete picture how species are responding. And it's not wrong to say phenology is changing and mostly it's, getting earlier in the spring and later in the fall with warmer temperatures. That is true, but it's also much more nuanced than that when we start looking at different species and different events and different regions. And so this is all every data point is a piece of that puzzle that can help us better understand actually what's going on and what the consequences might be for other species on the landscape and us too, humans.
So, are there notable examples about how this data has influenced gardening and agricultural decisions?
Yeah, so there's, again, kind of like I mentioned earlier on, there's a long history of using phenology in agriculture. And honestly, that application far predates climate change research. Prior to scientists acknowledging that the climate was changing, agriculture was the primary field in which phenology was cared about. Honestly, most other people didn't care a whole lot. And yes, your questions earlier about indicator species is really the primary way in which phenology came into play. There's a decent amount of interesting historical documents that talk about things like how agriculturalists and folks in all different countries have used phenology to guide their activities. I found this cool example that in Europe, folks used to know to graze livestock and in particular cattle when the apple trees started to blossom. And back in the 1950s and even prior to that, the flowering of snowdrop or galanthus was used to predict like several weeks in advance when later season events would occur. And it's similar to that. I found evidence that in Norway, they used to use flowering in willow to be able to predict when things like lilacs and apples and raspberries were going to be ripening. Stuff that was happening up to 3 months later, they would look at when willow was flowering in the spring to say, okay, it's earlier this year, so we think that raspberries are going to ripen earlier 3 months down the road. So be ready. So yeah, there's a very long, storied history of phenology being a part of agricultural practices and gardening.
How reliable are these phenological indicators in predicting things like frost dates? Because I know gardeners always have, we have an average date. How can we predict when that's going to happen?
Yeah. So where the predictions work well is when it's two biological events that are responses to environmental conditions. And so again, that the salmonberry and the Swainson's thrush is a good example because those are biological activities that are both responding likely to temperature. It does get muddly because there are also these indicators or folklore adages that we tend to refer to. Things like, if the woolly bear caterpillars are more black, we're supposed to have a rougher winter, or the groundhog. Oh my gosh, of course, the groundhog. Everybody knows about Punxsutawney Phil, and he's going to tell us how much more winter we have on the horizon. Those kinds of indicators don't tend to work so well because that isn't necessarily a situation where we are looking at an interpreting a biological response to environmental conditions. It's more just like, can we see the future with what this species looks like? So I think the groundhog has about 30% accuracy. It doesn't perform well. Largely, I don't know of any biological indicators that can tell us something about what subsequent weather or environmental conditions are going to be like. Like, there's no biological indicator that can tell us when a frost is going to occur. It only really works the other way around, where if we were trying to identify when the biological thing was happening because of the frost, that's where these things actually hold up.
So what are some simple observations that gardeners can start making in their own gardens?
So I did peek at the list of species that we have available in Nature's Notebook because, again, there's close to 2,000 of them now, so it's a lot. We do have a number of plants that folks might have in their gardens, things like wheat and corn and apples and pears. And then we also have a lot of plants that are just likely to be in your yard, either because you put them there, like sunflowers, or because they put themselves there, like dandelions. And then we have a lot of common and even not as common herbaceous plants and trees and then increasingly too animals that you might encounter. So some birds. The animals are only about maybe like 20% of the species that are available, but we do have some common and easily identified insects on there, and some mammals, some amphibians and reptiles, a few fish if you happen to be in an aquatic or marine environment. The reason why our species list is getting so long is that we keep adding to it to accommodate folks that want to participate and say, hey, I can't find anything on your list in my yard. Can we add that? So we have continued to add things over the years. And so hopefully there are things on there that look familiar to folks. Lilacs is definitely one that lots of folks have and tend to observe and are very visible and very lovely. So we have lots of data on lilacs.
Well, it sounds like there's plenty of options if Washingtonians want to participate.
I think so. Yeah, that's the goal.
All right. Any last thoughts you'd like to add?
If folks are interested in learning even more about phenology, I have a book coming out next March, simply titled Phenology, and it is intended to be an introduction to the topic. It basically covers what is phenology and why do we care and how is it changing, and a lot of what we covered in this podcast, honestly. So if folks are interested, it'll be coming out through the MIT Press, and you actually can pre-order it already now.
Great. All right. Well, thank you for joining me today. This was fun. I learned a lot.
Thank you so much. I had a really nice time. It was really fun.
Thank you for joining us on this episode of The Evergreen Thumb, brought to you by the WSU Extension Master Gardener Program volunteers and sponsored by the Master Gardener Foundation of Washington State. We hope that today's discussion has inspired and equipped you with valuable insights to nurture your garden. The Master Gardener Foundation of Washington State is a nonprofit organization whose primary purpose is to provide unifying support and advocacy for WSU Extension Master Gardener programs throughout Washington State. To support the Master Gardener Foundation of Washington State, visit www.mastergardenerfoundation.org/donate. Whether you're an experienced Master Gardener or just starting out, the WSU Extension Master Gardener Program is here to support you every step of the way. WSU Extension Master Gardeners empower and sustain diverse communities with relevant, unbiased, research-based horticulture education. Reach out to your local WSU Extension office to connect with Master Gardeners and tap into a wealth of resources that can help you achieve gardening success. To learn more about the program or how to become a Master Gardener, visit mastergardener.wsu.edu/get-involved. If you enjoyed today's episode and want to stay connected with us, be sure to subscribe to future episodes filled with expert tips, fascinating stories, and practical advice. Don't forget to leave a review and share it with fellow gardeners to spread the joy of gardening. Questions or comments to be addressed in future episodes can be sent to hello@theevergreenthumb.org. The views, thoughts, and opinions expressed by guests of this podcast are their own and do not imply endorsement by Washington State University or the Master Gardener Foundation of Washington State.